With Pipeline, you can create smart contracts and dApps visually by composing graphs. Graph nodes can now be smart contract functions, WASM functions, or any previously created graph. In the live version of Pipeline, you can find some contracts and WASM modules already loaded for testing. But if you want access to more contracts, use the Pipeline and ChainLens plugins from the Remix IDE. Link to the tutorial in the description. So let's create our first graph with some smart contract functions. And a WASM module function. We can make a connection between inputs and outputs as long as the value types are equivalent. So what happens here is we get a vendor address based on a product ID that we will give the graph, and then a number representing the quantity of a product based on the product ID and the whey value, which is the amount of whey that we want to send as payment. And we then add another value to the returned quantity through the sum function from the WASM sums WASM module. Now let's see the output. We don't have any Solidity code because the graph is mixed, but we have JavaScript source code, where each node was resolved to the appropriate source. Ethers.js is used to load each smart contract using its ABI and Ethereum address. And the WASM modules are instantiated from their URL, and this is each graph step. Now we can run the graph. And we get the result. And in the browser logs, we can see the intermediary values, the vendor address from the first step, the quantity, which is 100 in hex format, and the final result, which was the quantity plus 50. Now we can save this graph, and we can provide documentation for the user. And we can add placeholders for the graph's inputs and outputs, which will be replaced by actual runtime values when a user runs our graph. And now we can save it. And we can see it here. We can load it. And we can see how our markdown is populated by the runtime values it referenced. And this is our result. Now we can also use this graph as another node in a graph. And we can add another WASM function. In the JavaScript source code, we can see that this subgraph is treated as a graph step and wrapped in its own function. And the return value is used here in the last step, which is a function that subtracts a value from another one. So let's run this graph with the same arguments that we gave it before and subtract 20. And we have our result. If we look at the intermediary values, we can see 150, which is the result of this subgraph, and then 130, which is the result of subtracting 20 from 150. We can again add some Markdown documentation and save this graph for reuse, but we just created a dApp with smart contract and WebAssembly functions by composing and nesting graphs. So stay tuned for updates on how to add and use more WASM modules.